Hello everyone, welcome back. In today's video, we're going to look at the different keywords we have for declaring variables in JavaScript. So we have let, const, and var, and each of them behave differently. So we're going to look at the differences between them and how they behave in terms of hoisting and scoping. When you declare a variable with the var keyword in the global scope, that variable will be added as a property on the global object. But variables declared with let and const are not added as properties on the global object. And the global object in this case is the window object. So the window object is the global object in the browser. Now, let me explain this better with this snippet here. In this program, the global scope is the outermost part of the program here, right? It contains everything, and the variables declared in the global scope can be accessed anywhere in the program, right? So now in the global scope, we have three declarations. We have these two variables, x and y, and then we have this function here called hello. Now, like I said earlier, when you declare a variable with the var keyword in the global scope, it gets added as a property on the global object. So inside this function, we're using the global this property to access the value of x and y here, x and y there in the global scope. And we're accessing the value of x and y from inside this function using the global this. And the value of global this here points to the window object. The global this here points to the window object. So when we console log global this, right here, when we console log global this.x, one gets printed to the console. But when we log global this.y, we get undefined. Why are we getting undefined? They're both declared in the global scope, right? So why do we have access to x and we don't have access to y? This is because variables declared with the var keyword in the global scope are added as properties on the global object. But variables declared with let and const are not added as properties on the global object. So see here, we're saying global this.has own property x, right? The method has own property here will tell us if the global object has a property on it called x, right? See, we get true. We're also asking if the global object contains a property called y, and we get false because this variable was declared, y was declared with the let keyword. Now, if we change let here, if we change let to const, right, we still get the same result because variables declared with let and const in the global scope are not added as properties on the global objects. They're just global variables, but variables declared with the var keyword are added as properties on the global object. Now, since the window object represents the global object, we can log window.x to see if the window object contains a property on it named x, and see we get true. But window.y, nope, we get false. It was declared with let. Now let's see how variables declared with these keywords behave in terms of hoisting. Hoisting in JavaScript is the process where memory is allocated for all the variables and all the functions defined in a program before execution starts, before JavaScript or the JavaScript engine starts executing that program. Memory is allocated for all the variables and all the functions defined in that program. This happens during the memory creation phase. So I have a video where I explained how the JavaScript engine executes our code, and I'll leave a link to that in the description. But in summary, when a function is invoked, when a function gets invoked, a brand new execution context gets created and added to the call stack. In this case, when this program runs, a brand new execution context is created and added to the call stack. This execution context is called the global execution context, right? And then inside that execution context, there are two phases, the memory creation phase and the code execution phase. The memory creation phase happens first. So during the memory creation phase, the declarations in that program, in the global scope, are added. All the variable declarations, all the function declarations are added to the variable environments. They're added, they are allocated a space in memory, right? Now, it happens before our code starts getting executed, right? So having that in mind, having this in mind, what happens in the memory creation phase, let me explain better with this example. So I'm just going to delete all of these and declare a variable with const z is equal to 3. remove these. Okay, now at the top here, if I try to log the value of x, see, we get undefined, right? This is because during the memory creation phase in an execution context, variables declared with the var keyword are initialized with a default value of undefined, right? So during the memory creation phase, the declarations get assigned a space in memory. The declarations here, not the assignments, not their values, right? During the memory creation phase, all these declarations, x, y, z, this function here, they'll all get assigned a space in memory, but they won't get initialized with their values yet, right? So the difference between these variables here is what they get initialized with during the memory creation phase, right? So during the memory creation phase, x will get added to memory and it will be initialized with undefined because it was declared with var. Then during the execution phase, when it gets to this line that says var x is equal to 1, it will then assign the value 1 to x, right? So here, when we try to access the value x holds before this line where its actual assignment is done, we get undefined. But if we try to log the value x holds after the assignment, we get 1, right? So during the memory creation phase for variables declared with var, it does something like this. In the variable environment in memory, it does something like this. During the memory creation phase, it does x, right? Now that's why when we try to access x before the line where its actual assignment is done, we get undefined. Now variables declared with let and const are also hoisted during the memory creation phase, right? But the difference is that they don't get initialized with undefined or any other value, unlike variables declared with var. So if we try to log y to the console at the top here, we get a reference error saying y is not defined, right? And it's the same if we try to log z as well. So these variables can only be accessed after they have been assigned or initialized with their values during the execution phase. So if we try to log them to the console here, see, we get 2 and 3, right? But from the beginning of the program till we get to these lines where they're initialized with values, they're in what is called the temporal dead zone, right? A temporal dead zone is the time from when a variable, that's the declaration, is added to memory during the memory creation phase. And when it's initialized, the time in between is called the temporal dead zone. And the variables cannot be accessed until they're initialized. If you try to access it during this time, you'd get a reference error. Now that's it for hoisting. Let's see how variables declared with these keywords are scoped, right? Now in JavaScript, we have two types of scope. We have the global scope, which we've seen, and then we have the local scope. Under the local scope, we have function scope and block scope. So I have a video on scopes in JavaScript and I'll leave a link to that in the description so you can check it out, because in this video I won't go into the details of lexical scoping, right? Just how variables declared with these keywords behave when they are in different scopes. Now variables declared using let or const are block scoped, right? Their scope is limited to the nearest pair of curly braces, and they can't be accessed outside of their block. They can't be accessed outside that scope. So let's see how that works. If we move these variables, y and z, if we move them inside this function, right, we won't have access to them again from outside this function in the global scope, right? See, we get a reference error saying y is not defined. And it's the same thing if we log x, we get the same result, right? So this is a function scope. But even if we have an if statement, now if statements, while loops, for loops, they also create their own local scope, right, within the curly braces. So if we have an if statement, if true, and we move the variables y and z into it, we won't have access to these variables outside this if block again. If we try to log y to the console here in the global scope, we get a reference error saying y is not defined, right? Because it's not available in this scope. It's only accessible within this pair of curly braces. So if we log z to the console from inside here, we get 3, right? So these variables declared with let and const, or variables declared with let and const, are only limited to their block. These variables are only limited to this if block. Now, if we move this variable x declared with the var keyword into this if block, right, and then we try to access it from outside the if block, from the if we try to access it from the global scope, see, we get 1, right? This is because variables declared with the var keyword are not block scoped. They have function scope. Variables declared with the var keyword have function scope. So this variable is not scoped to this if block, and that's why we can access it from outside the block, right? But if we move the variable from the if block inside the function body, right, and then we try to access it from outside, see, we get a reference error saying x is not defined. So variables declared with the var keyword are function scoped. They're scoped to their outermost function. But variables declared with let and const are block scoped, right? Now the last point is, if you declare a variable with the let keyword within a scope, the global scope, function scope, just within a scope, if you declare a variable with the let keyword within a scope, that variable cannot be redeclared within that scope. So with this example, we have this y variable declared here with the let keyword, right? We cannot come down here and say let y be equal to 4, right? We get a syntax error saying the identifier y has already been declared. So variables declared with the let keyword cannot be redeclared in the same block. They cannot be redeclared in the same scope, but they can be reassigned. So we can say y is equal to 4, right? It's still the same variable. It's still the same y variable here. We're just reassigning it. Now, if we log y to the console, we get 4, right? But within this scope, we cannot declare another variable y, because we've seen that variables declared with the let keyword are block scoped, right? So this variable is scoped to this block. But variables declared with var can be redeclared in the same scope with the same name, right? They can be redeclared, so they can be reassigned. Now, if we come down here and say var x is equal to 10, see, it works, right? It's still the same variable, we're just redeclaring it. If we log the value of x, see, we get 10, right? Now, if we redeclare x inside this if block, right, we know variables declared with var are not block scoped. They don't respect blocks. They're function scoped. So if we redeclare x inside this if block, say x over x with the var keyword is equal to 8, right? If we log the value to the console from the global scope, see, we get 8. The new variable is replacing the old one, right? So variables declared with var can be reassigned. They can be redeclared, they can be reassigned. But variables declared with let cannot be redeclared. They can be reassigned, but not redeclared. Now, variables declared with const cannot be redeclared or reassigned in the same scope. They're constants, right? So we cannot come down here and say const z is equal to 5, right? We get a syntax error saying that the identifier has already been declared and we can't reassign a constant value. So that won't work, right? But when you declare a variable with const and assign that variable to an object, right, or any of the object types, that variable cannot be reassigned to another object. But the properties of that object can be changed. If it's an array, the elements of the array can be changed. So let's see. Let me remove all of these. Right? Now, if we have, for example, const pets is equal to an array, dog, cat, right? Now we can change the first element in this array, regardless of the fact that it was defined with const. We can say pets at index 0 is equal to goat. Right? Now, if we log pets to the console.log pets, right? We get goats and cats, but we can't reassign pets to another object. We can't reassign the variable pets to now hold something else. If I say pets is equal to an object, right? We get a type error for trying to reassign a constant variable. Now that's it. One last thing. This was supposed to be the last one, but this is also very important. Variables declared with const must be initialized with a value, right? You must assign a value to that variable when you declare it. As you're declaring it const, whatever is equal to, you must initialize it with a value. For example, I cannot say, let me remove this const pets, right? It won't work. We'll get an error. We'll get a syntax error saying missing initializer in const declaration. But variables declared with var or let do not have to be initialized with a value when they're declared. It's optional, right? But variables declared with const must be initialized. And that's it for this video. We've come to the end of this video. Thank you so much for watching. I hope it was helpful. In the next video, I'm going to be talking about hoisting in JavaScript next week. That's what I'm going to be talking about in that one. Thank you so much for watching again. Please subscribe if you haven't already. And I'll see you in that one. Bye.